Good day, students. My name is Mr. Seun Akinmolayan. I teach physics at Sleek Angels International School, Port Harcourt. I'm glad to bring this video class to you. And this class is for the SS2 students. We are looking at lenses today, where we shall concentrate on solving some problems on lenses. We have dealt with lenses theoretically, where we said lenses, basically we have two types. Basically we have the convex lens and the concave lens. The convex lens is also called the converging lens, while the concave lens is called the diverging lens. And each of these lenses have their way and formations of images. They have different ways of formation of images. So basically, let's look at the lenses. Here we have convex lens. These are the examples. These are examples of convex lenses. Convex lens bulges outward. It bulges outward. So this is an example of a convex lens. Also, for the concave lens, we have this. A concave lens bulges inward, so the inside is thinner than the round edges for a concave lens. So these are examples. All right. Having said that, we will look at some calculations. We solve some problems. We have the first example here. We have said that the formulae that we need to use to make calculations in lenses are the same with those of mirror. And so we have dealt with mirror in the past. But today, those formulae are still valid, and we're going to use them to solve this problem. All right, so example 1. An object 3.0 centimeters high is placed 60.0 centimeters from a converging lens whose focal length is 20.0 centimeters. Calculate the size of the image formed. Calculate the size of the image formed. So, having this question, let's look at our parameters. What are the parameters we are to use? An object 3.0 centimeters high, that's object height. Object height. So let's call that H0 equals 3.0 centimeters. Then placed 60 centimeters from a converging lens, that's object distance. Object distance U equals 60.0 centimeters from a converging lens whose focal length is, so we have our focal length F equals 20.0 centimeters. Okay, now we're to calculate the size of the image formed. Before we can calculate the size of the image, we need to find the distance of the image. Before we can calculate the size of the image, we need to find the distance of the image. So using this formula, using 1 over F equals 1 over U plus 1 over V. 1 over F is the focal length, U is the object distance, V is the image distance. So we need to find the image distance. That will now help us to find the size of the image, that's the height of the image. Okay, so let's substitute our values here. From here, 1 over 20 equals 1 over 60 plus 1 over v. Okay, so if we make 1 over v the subject, from here we have 1 over v equals 1 over 20 minus 1 over 60. 1 over v equals 1 over 20 minus 1 over 60. Okay, so from here you can find the LCM. The LCM of 20 and 60 is 60. So these equals, the LCM is 60. And then 1 over 20, so 20 in 60 will be 3. 3 times 1 will give you 3. Minus 60 in 60 is 1. Then 1 times 1, we have 1. Okay. Therefore, 1 over v equals 2 over 20, such that if you make v the subject, we have 2v equals 60, 2v equals 60. So v equals 60 over 2. So from here, v equals 30 centimeters. So the image distance equals 30 centimeters. Now we can go on to calculate the size of the image. From our understanding, we know that magnification m equals image distance over object distance equals image height over object height. So from here, magnification equals, let's call our image distance to be, image distance is v, object distance is u, equals image height, let's call it ih, and then object height oh. So if you substitute that, we can have 30 over u. U has been given to be 60 equals image height, that's the size of the image, over object height. We have been given our object height to be 3.0. Alright, so from here you have 60 times the image height, that's the size of the object image, equals 3 times 30. From here, the image height or the size of the image equals 90 over 60. So if 0 cancel 0, then 9 over 6. Image height equals, from here, 3 can go here, 3 can go here, 2. So automatically, h height equals 1.5, and that is the image size. That's the image size. So the image size therefore is 1.5 centimeters. 1.5 centimeters. That's the image size. Alright, so let's move on to the second example. Alright, we look at the second example under lenses. Example 2. The magnification of an object produced with a converging lens of focal length 15 centimeters is fine. If the image is real, what is the separation between the object and the image? The magnification of an object produced with a converging lens or focal length 15 centimeters is 5. If the image is real, what is the separation between the object and the image? What is the distance between the object and the image? Before we go on to solve this question, I want you to understand that for an image to be real, using lenses, the image must be behind at the other side of the lens. And the lens that can produce such image is the converging lens. So the image of converging lens, or the images produced by converging lens, are always real. They are formed behind or at the other side of the lens, except when the object is between the focal point and the optical center of the lens. That's when you have a virtual image that is formed at the same side of the object. So a virtual image is formed when the image is at the same side where the object is placed. Okay, so let's look at the solution to this question. The magnification of an object, so we're given magnification M equals 5. We're given the focal length F equals 15 centimeters. Alright, so we're asked to find the distance. So if the object distance U, let it be U, we're not given that. Image distance V, we're not given as well. So you now need to think of a right formula to use so that you can find the image distance, after which you also find the object distance, and then you can now get the separation between them. Okay, so using M equals V over F minus 1, where M is the magnification, V is the image distance, F is the focal length, and then you have minus 1, that's a constant. So let's substitute our values. So we have 5 equals V over 15 minus 1. So from here, you can bring minus 1 to the left hand side. So 5 plus 1 equals V over 15. So from there we have 6 equals V over 15. If you cross multiply from here, there, you have 6 times 15 equals V. So this will give you 90 equals V. Therefore, image distance V equals 90 centimeters. So the image distance equals 90 centimeters. But the question now says we should calculate the separation between the object and the image. So the next thing to do is to find the object distance. So let's go ahead and find the object distance. So to find object distance, we have 1 over f minus 1 over u plus 1 over v. So if you make 1 over u the subject, 1 over u equals 1 over f minus 1 over v. Let's substitute 1 over u 1 over u equals 1 over 15 minus 1 over 90. Find the LCM here. LCM equals 90. So 1 over u equals, then you have your LCM 90. 15 in 90, that's 6. 6 times 1, that's 6, minus 90 in 90, 1. 1 times 1, 1. So 1 over u equals 5 over 90. That is 6 minus 1 give you 5. So if you cross multiply, 5u equals 90. U equals 90 over 5. And that will give you 18 centimeters. So the distance between object and image equals u plus v, because since we were told that the image is real, it therefore means that the image is formed at the other side of the lens. For an image to be real, it must be formed at the other side of the lens. And so from here, we now have distance equals, since our u is 18 centimeters, and then our v, we got it to be 90 centimeters. Therefore, the distance equals 108 centimeters. So the distance between the object and the image is 108 centimeters. Is that clear? All right, let's take the assignment for today. The first question is, an object placed 30 centimeters in front of a lens forms an image 12 centimeters in front of the lens. A. Find the focal length of the lens. B. What type of lens is this? And the second question. A picture of height 25 millimeters is to be enlarged to a height of 1 meter by projecting it into a screen which is 5 meters away from the projector. A. Calculate the distance of picture from the lens. B. Calculate the focal length of the lens. Alright. Attempt these questions and please forward it to me through my WhatsApp number 080-3479-6589 or my email princeoluwaseun91@gmail.com. I'm of the opinion that you enjoyed this class today, and then you have the understanding now to know how to solve problems using the lens formulae. Till another class, stay healthy and stay safe. Bye.